So, for today we are going to discuss about few important points for your competitive exams. Alright, so for your NEET and JEE, okay, so for the JEE exams as well as for the NEET examination, so we will see what are the important things. Before starting with the multiple choice questions, we will go through this session and then we will start over with the multiple choice. Okay, so there are few important competitive points which I am going to stress in this particular video. So, when we are speaking about hydrogen, the reactive forms are available in two different varieties. That is, this particular hydrogen reactive forms are two. And those are what we call it as, first one, atomic hydrogen. And of course, the second one, we call it as a nascent hydrogen. Okay, now atomic hydrogen, when we are speaking about this, we usually write hydrogen in its molecular form as H2, right? Now, when we have that hydrogen molecule, as we supply energy to it. Now, supplying the energy is in a form of electricity or is in a form of heat. Okay, so when you supply heat to this particular hydrogen molecule, so this hydrogen molecule breaks down into its constituent atomic particle, right? So, atomic state of hydrogens are available, okay, when we supply heat to the hydrogen molecule. So therefore, we are speaking about this particular hydrogen over here, that is the hydrogen in its atomic form, atomic hydrogen. So this particular atomic hydrogen is formed when we have hydrogen gas, and this particular hydrogen gas is passed. We are going to pass this through tungsten or platinum. You can use either one of these. Okay, and when we do supply good amount of heat at this particular temperature, and the heat that we are going to supply here is going to result in breaking out this particular hydrogen molecule into its atomic state. Now, this particular atomic hydrogen, what we are getting here, these atomic hydrogens are quite very reactive. Reactive in the sense that these particular atomic hydrogens are strong, reducing agents. Okay, so one of the form of hydrogen is called as an atomic hydrogen, and this particular atomic hydrogen we can get it by supplying heat or electrical energy, and when we do that, the molecular hydrogen splits up into its atomic state. Now, this is done usually by taking into consideration of metals such as vanadium or platinum, right? Now, here the amount of energy that you have to spend in order to break down this particular molecule of hydrogen is around 436 kilojoules of energy is required. This is how we are going to break it down. So, one more thing that we have to understand here is these particular atomic hydrogens usually combines with metals or with non-metals. It reacts with these things in order to form hydrides. Correct? So now, taking a look into the next section section, and that is what we call it as the nascent hydrogen. Now, when we are taking a look into the nascent hydrogen, first thing that you have to understand that this hydrogen is usually represented in the bracket like this. Okay, so that is a nascent hydrogen. Now, nascent hydrogen means that this particular hydrogen is just born. It is a byproduct of a chemical reaction. So you can say as nascent hydrogen is nothing more than just born, or it is a byproduct of a chemical reaction. Alright, so it is going to be a byproduct of a chemical reaction. Next thing that we have to understand that is this nascent hydrogen is quite a very powerful reducing reagent as when we compare to that of a normal hydrogen. Okay, so therefore, second point what we have to clarify is this nascent hydrogen is quite a very powerful or a stronger reducing agent. Now, reducing agent when we do compare as compared to its ordinary hydrogen. So it's quite very powerful than a normal hydrogen. Okay, now we will see as what kind of the reaction which are going to give us nascent hydrogen. As it says that these particular hydrogens are nothing more than byproduct of a chemical reaction. Okay, so if you do take into consideration of, let's say, zinc. Whenever we react zinc this with dilute H2SO4. Okay, so now sulfate section combines with zinc in order to give us zinc sulfate. Correct? Now what comes aside, just born, that is nothing more than hydrogen. Now hydrogen is getting evolved. This is how the reaction happens. Coming forward with the second type of reaction here, let us see about Sn represents stannous. Stannous, or you can call it as a tin. Okay, now stannous when it is reacted with dilute HCl. Okay, so dilute HCl, what will happen is Sn, that is tin or stannous, has an oxidation state of +2. So we have Sn as +2. Okay, so in order to balance these two, we have chlorine. But chlorine has an oxidation state of -1. Okay, so this is -1. I can write it down like this also over here. Okay, so -1 here +2. In order to compromise the charges, what we can say is we are going to have here SnCl2. This is how you have to compromise the charges, balance the charges. Okay, so +2, Cl is with -1 into 2. So 2 chlorines will be attached to stannous, and that will become as SnCl2 plus H2 is going to be evolved. So if I am taking a look at a balanced chemical equation, then I can write it down as 2HCl in its direct form. Okay. Coming forward with the next one, given by iron. When we take iron and react this particular iron with dilute H2SO4. Okay, what happens is Fe combines with sulfate section, leading forward to the formation of FeSO4 plus what we are going to have is hydrogen being evolved. Correct? So this is how the reaction happens. This is how we are going to produce the nascent hydrogen. Okay, so coming forward with the next concept, and that is the isotopes of hydrogen. We know that hydrogen is basically formed of three different isotopes. Correct? So, the three different types of isotopes are ordinary hydrogen or protium, right? The second type is deuterium, and the third type, as what we have, is tritium. Now, in protium or normal hydrogen, atomic hydrogen, we do not have any neutrons. So, the number of neutrons in this particular case, neutrons are 0. In deuterium, there is a presence of one neutron, while in protium, there are two neutrons. While, of course, the number of protons in this remains 1, 1, and 1. Correct? Now, in this entire case, what are the important facts that we have to remember is that protium forms almost 99.98% of its constituent at a normal room temperature, while deuterium is available as 0.02%. Now, in the chemical reactions, it is usually the deuterium and tritium which are used. These things are used as in the form of tracers in order to understand the chemical mechanism. Now, what is the meaning of this? If you observe proton and deuterium, protium and deuterium, what difference is there? Is with respect to the neutron value. That means the mass of deuterium is far more than the mass of protium. So whenever a reaction is occurring with respect to deuterium, whenever we are taking deuterium and we are inserting that deuterium into the reaction system, that time what happens is this deuterium, because of its heavier mass compared to that of normal hydrogen, reacts slowly. It helps us in order to understand the chemical mechanism as how the reaction is occurring, where that particular deuterium is going and attaching, or the proton will go and attach. These things are learned by the help of tracers in a chemical mechanism. Okay, so deuterium and tritium are usually used as tracers in chemical mechanism. Third important thing that we have to remember is that the tritium is the rarest of all, and it is also radioactive in its nature. Correct? So, coming forward with the next important section, and that is going to be the preparations. That is the preparation of hydrogen by various methods. Now, in our day-to-day or in the simple NCERT, we have decided to reduce it. But this one I am taking it only for your competitive part. Because I do not want to take any risk, let's get started. So, when we are speaking about preparation of hydrogen, so here there are various of methods by which we can use it for the preparation of hydrogen. Okay, so starting with the first one, and that is going to be the electrolysis method. So, electrolysis of acidified solution of potassium hydroxide. Okay, so now first thing that we have to understand is the process of electrolysis. In the process of electrolysis, what we have is a big tank or a container in which we are first going to fill up the solution of KOH. Now, in this particular thing, we are going to dip in 2 rods. Now, the 2 rods that what we have dipped over here, once it is connected to battery, once it is connected to battery, what happens is it will start to generate charges. That is, the one particular metal that has been connected to the positive terminal of battery acts as anode, while the another one which is connected to the negative terminal of battery acts as a cathode. And this is the cathode here. Okay, so positive and negative. Alright, so once we connect the batteries, this particular potassium hydroxide solution dissociates. It dissociates as KOH dissociates in order to form K plus OH minus. Now, in order to balance this, let us say that I'm going to take here 4 molecules of potassium hydroxide, dissociates in order to give 4 moles of potassium ion plus 4 moles of OH minus ion, hydroxide ions. So, here at anode, when we take over here at the anode section, now at the anode, that is nothing more than the particular electrode with the positive charge. What happens is the negative charged ions will start to flow towards anode. As it reaches the anode, it transfers its electrons. It transfers this extra electron to this anode. Okay, so if I'm going to take over here 4 OH minus. Now, this minus means it is 1 extra electron there. So therefore, once it comes near the anode, this particular electrons are supplied to this anode and it becomes as 4 OH plus 4 electrons. These electrons are carried by anode, goes to the battery, from the battery it goes to the cathode section. Okay, so now 4 OH over here, it's not stable compound. It's not at all stable. OH molecule is not stable. So therefore, now what will happen is this one will break down, rearrange itself in order to form what it is forming is water. As there are 4 hydrogens, 2 H2O. What remains is 2 oxygens, and that 2 oxygens are evolved in the form of gas. That means from this section, the oxygen gas is evolved. Now, what remains with us is the second part of it, and that is very important at cathode. So, the reaction occurring at the cathodes are very important, because here the acidified section, what is meaning of an acid over here? That we have a lot of H plus ions. Now this H plus ion will come into consideration when we are speaking about the cathode. It's not the K plus ions. I'll give you the reason at the end. Okay, so therefore when we are speaking about this, what will happen is the H plus ions will take the electrons and it gets converted into simple hydrogen in its atomic form. Now, as we have released 4 electrons, let us say that we have 4 protons here, takes in 4 electrons, so therefore it will give us 4 hydrogen. Now, these 4 hydrogen atoms, as what we have, it will reorganize in order to give us hydrogen molecule. So it will give us 2 hydrogen molecules. So therefore, the 2 hydrogen molecules will be evolved at cathode. So if you take a look over here, that is the cathode over here, that means here is the hydrogen molecule which is going to be evolved. Correct? So this is about the hydrogen molecule. So now what remains is the question as why is not the K plus ions that can be released at the cathode? It is because of its discharge potential. So therefore here K plus has a high discharge potential. When we compare to that of H plus. So instead of K plus, there is a H plus ions which will migrate towards the cathode, gets the electron, combines in the form of hydrogen molecule and gets evolved. Right? So this is the main reason as why K plus ion is not released, or why K plus ion is not going to be evolved at the cathode. Now coming towards the next part, and that is called as the bosch reaction. In bosch reaction, what we do is we take steam. Water is taken in the form of steam, and this particular steam is passed through coke or coal at a very high temperatures. The temperature is kept to vary between 440 degrees Celsius to 660 degrees Celsius. Between these two, the particular temperature keeps on varying. Now, as we take steam, react with coke at a very high temperature, what happens is the oxygen gets transferred. That is, nothing more than your coke is getting oxidized. It gets oxidized in order to form CO plus H2. Now, this combination is very important. Okay, so this particular combination we call it as the water gas. It's called as water gas. Now, once this particular water gas that we have got, we take this further, react this again, pass it through the steam. But now, here we are going to use two important things. One is called as the catalyst, another one is called as the moderator. So, here we are going to use two important things. One is called as the catalyst and the another one is called as promoter. And in this particular case, we use Fe2O3 ferric oxide as a catalyst and Cr2O3 chromium oxide as the particular promoter. So here what happens is, again, carbon monoxide gets oxidized in order to give us carbon dioxide plus what we will get is hydrogen. That means the amount of hydrogen increases over here, and this carbon dioxide what we are getting here. This carbon dioxide is separated now. How it is going to be separated is by washing this with water. This is washed down. It is washed down with water at a very higher atmospheric pressure. That means we are going to pressurize it and then we are going to leave the water aside. Along with this, due to higher molecular weight of carbon dioxide gets suppressed, it goes down, while the hydrogen being lighter comes up. Okay, so it is going to be washed with water at higher atmospheric pressures. Now the atmospheric pressure that we are speaking of now 25 to 30 atmospheric pressure. Right? So coming forward with the next one, and that is called as the Lane's process. So in Lane's process as what we have here is, this is what we do is we take into consideration of a spongy iron. That means the iron has an n number of small pores in it. Okay, and this particular spongy iron is reacted with steel. Okay, so this reaction occurs at a very higher temperature, the temperature varying from 770 kelvins to 1050 kelvins. Now here, this iron gets oxidized to Fe3O4 plus whatever the hydrogen that we have here gets eliminated. Of course, the reaction is not balanced. In order to balance this particular reaction, let's take over here 3. And we have here as 4 oxygens, so let's take over here as 4. So therefore, what we have is 4 oxygens. 4 oxygens here. We have 3 ferrous, we have 3 ferrous here. What remains with us is the 4 hydrogens. And this particular 4 hydrogens will get evolved. Now, this was about the Lathes process. And that is the preparation of the hydrogens. So here we end with the preparation of hydrogen. There is one important concept that is remaining. Now, in order to explain that particular concept, let us take into consideration of few examples. The few examples that what we have here is, let's say we start with copper. CuSO4 dot 5H2O. Second example, let's say that we have Na2SO4 dot 10H2O. Let's say we have one more, MgSO4 dot 7H2O. Now, in this all things, in this all 3 examples, if we do see this section, 5H2O, 10H2O, 7H2O, these things are considered as the water of crystallization. Okay, so here water is getting associated with the salt type of compounds in order to form complexes. The same is a way when we take into consideration of heavy water. That means even the heavy water associates in a similar way as what ordinary water associates. So therefore, here heavy water, what we have is D2O. So chemically, even this particular D2O has the same effect on the complexes as what we had the ordinary water molecules. That means, if I am taking here into consideration of copper sulfate, CuSO4 dot 5 D2O. Okay, it's associating almost in the same manner. Now, second one, what we have is Na2SO4 dot, how many H2Os do we have here? Is it 10? So 10D2O. Okay, similar is the way when we have Mg. So magnesium sulfate MgSO4 dot 7D2O. Right? Now, these things, we call them as deuterated hydrates. So, deuterated hydrates, in a sense, we have heavy water in association with the salt complexes. And with this, we end up hydrogens. Okay, so therefore, in the next particular video, we will be taking a look into the multiple choice questions. So, take care. Have a great day.